So now we are going to look at homework assignment 1.03 number 2, the end behavior of rational functions. So the end behavior is what happens when x gets extremely large. In a case like this, our 13x plus 12 over 23x minus 12, when x gets into the thousands, the millions, the billions, these plus and minus 12 bits don't matter much. So this 13x plus 12 over 23x minus 12 becomes roughly 13x over 23x, which reduces to 13 over 23. So as long as the exponents of x are equal, the end behavior is going to be y equals to the ratio of those leading coefficients. That only works if they are equal. Here our numerator has an exponent that is greater than the denominator. This polynomial is a higher degree than the denominator. As x goes to infinity, this becomes like 3x squared or 3x cubed over 2x squared, which is like 3 over 2 times x. But x still climbs to infinity. We do not have a horizontal asymptote. So in this case, we've got the flip side. This is where the degree of our denominator is greater than the degree of the numerator. So as x gets larger and larger, this plus 19 and plus 25x are going to matter less and less until this roughly becomes 3x to the fourth over 15x to the fifth, which is roughly 1 over 5x. So you have that 1 over 5 here. It's tempting, but that x will kill it. This will go to y equals 0, because as x goes to 100, this is 1 over 500. When x is 1,000, it's 1 over 5,000, approximately. It'll get closer and closer to 0 as x gets larger and larger. Finally, the horizontal asymptote here, we do have equal degree. It's exponent 5 over exponent 5. So this one will behave like the ratio of the coefficients. So that's going to go to y equals 5 over 9. So this concludes our look at homework 1.03, assignment number 2.